कल जो फील्ड विजिट होगा उसमें देख लीजिए सैंपल कलेक्शन कैसे करना है। अगर इशू रह जाते हैं जो सैंपलिंग कलेक्शन मेथोडोलॉजी एनएबीएल एक्रेडिटेड लैब में सैंपल कलेक्शन अगर गलत करके लाएंगे तो डाटा पूरा कोई एक्सेप्ट ही हम लोग नहीं करते। हमारा प्रोसीजर में जाएगा फोटो कैसे रहेगा, क्वांटिटेटिव में आएगा, कौन सा ऐसे करना पड़ेगा, ये सारे वेरीफाई कर लीजिए। आप करके आए हम लोग बात कर रहे थे कुछ जैसे ऐसे मिल रहा है। तो अल्टीमेटली क्या है, आप होटल में जाएंगे वहाँ पे जाके आपको सप्लाई फॉर द विलेजर्स आपको प्रोवाइड करना पड़ेगा। तो बेसिकली क्वांटम सिर्फ नहीं है, क्वालिटी एस्पेक्ट भी जांच करना जरूरी है।
Good afternoon. So now I introduce our next faculty member, Dr. DJ Khound sir, Scientist D, CGWB Guwahati. So now I request to Vikram sir. Welcome to Gamcha, DJ Khound sir. So now next faculty member, Mufi Mili ma'am, Scientist C, CGWB Guwahati. So welcome to Vikram sir. Thank you. So now I request to DJ Khound sir.
ग्रुप बना है ना इन लोग का, प्रेजेंटेशन शेयर किया जा रहा है इन लोग को, ये कर दीजिए इन लोग को प्रेजेंटेशन शेयर एवरीडे, ताकि इन लोग एक प्रेजेंटेशन लास्ट डे के लिए तैयार कीजिए तो ग्रुप में बात हो जाए आप लोग का बीच में। नहीं तो क्या होगा, वो मीनिंगलेस हो जाएगा। आप सुना कुछ, ध्यान ही नहीं दिया, छोड़ दिया। जब ग्रुप में बैठेंगे और एक प्रेजेंटेशन कुछ बनाएंगे वो थोड़ा ब्रश अप हो जाएगा और इन्वॉल्वमेंट भी होगा। नहीं तो जनरली क्या होता है, वो लेक्चर चलता रहता है, आधा सुना आधा ऊपर से गया, कोई इन्वॉल्वमेंट नहीं। तो आप लोग का बीच में दो ग्रुप काल तक क्लियर कर लीजिए, लीड ले लीजिए, घूमिए घामिए, थोड़ा टाइम बैठिए रात में एक साथ मिल के, क्या हम लोग सुना, क्या सीखा, कहाँ पे हमें गेट रहेगी, ताकि ये वन साइडेड हो जाएगा। नहीं तो हमें नेक्स्ट टाइम में रेक्टिफाई करने के लिए भी हमें भी मौका चाहिए ना। ये चीज़ हमें क्लियर नहीं हुआ, वो चीज़ और क्लियर होना चाहिए। ऐसे चीज़ का या कुछ जानकारी में है, कुछ बेटर आप लोग देखते हैं,
इसको कलर में ठीक है। Very good afternoon. Actually, we have done this workshop year and year again only to train our manpower, because spring is an important source, all of you are know very well, and it is supplying water to millions of people. So it is very much important to geotag our spring locations, and also to know the dependability of the different communities on spring water and spring quality, and all these things, and we try to give water security to all these communities. To give water security all these people, we need to know how much of water is available in our springs, or how much water we can expect from the spring, so that our population can get water. For this, we need to know the what is the volume of water in the spring aquifer, and what is the type of research in our spring area. So before going this topic, we want to clear two definitions. What is dynamic storage? Because in our topic it is written as estimation of dynamic storage and spring research. So there, the diagram in the left side of the left side, it shows that this is the water table, and this is the blue portion, and this is the spring line. That means below, if the water below this line, if water is available in this line, then it cannot supply to spring. Only this upper portion, water table to the spring line, this portion only can feed our spring. So by definition, it is said that volume of stored water in the saturated zone above the outflow spring level is termed as the dynamic storage of the spring. So this is our dynamic storage. That is the water inside our spring aquifer. And what is research? Research is the process of adding new water to our system. And how this water is coming from? It is mainly coming from rainfall, infiltration, snow melt, or seepage, etc. To know research, we must see, we must know the hydrologic cycle. Let us see, this is our hydrologic cycles. Now rainfall will come. I think rain is not shown here, but after rainfall, the river is filled up, and river water or infiltration of rainwater rises up our water table. So this aquifer is now feeding our dry river. Now this process, evaporation process is evaporation or evapotranspiration process is dominant during the lean period. So during the monsoon, precipitation is dominant, evaporation or evaporation is less, but during the dry season, evaporation is more, no rainfall, and aquifer is feeding our natural system, that means surface runoff bodies. So what is the difference between dynamics spring storage and spring research? What it actually means, that water currently stored in the aquifer that is feeding our spring. That is this dynamic spring storage means water stored in the aquifer and it feeds our spring. And spring research, water entering the aquifer from rainfall or infiltration, as we have seen in our hydrologic cycle. And when it occurs, after rainfall has stopped during the period of recession, and research occurs when there is rainfall or infiltration period, during infiltration period. And direction of the water movement, how water will move from aquifer to spring, and it is from surface to aquifer. That means one is horizontal flow is dominant and another is vertical flow is dominant. And dynamic storage represents depletion or release of groundwater. And spring recharge means replenishment or gain of groundwater. And who controls dynamic spring recharge? Definitely the aquifer property, that is the transmissibility, storativity, permeability, and another important factor is recession coefficient. Whereas spring recharge is controlled by rainfall, infiltration rate, land use pattern, different types of things. So here we comes to know that there are two terms which we need to understand. First is recession and recession coefficient. This is the spring discharge hydrograph. This is hydrograph because we are plotting discharge which we can able to measure, discharge versus time. If we plot discharge versus time, then it will give a graph like this, where there is a peak point, this is denoted by P, and if you draw a line, then left hand side of the line, that is the AP, this is known as the rising limb, and the right side, that is PC, this is known as recession limb. That means in the AP side, rainfall is dominant, precipitation is dominant, evaporation or transpiration is less. But in CP line, precipitation less, evaporation and evapotranspiration is more. And spring discharge hydrograph provide useful information on the aquifer characteristics, such as the nature of storage, transmissibility, types, and quantity of groundwater reserve. Actually, why for us what to manage? Because during the rainfall, there will be generally there is an increase in spring discharge, so there is no problem. That means A to P, we need not have to worry much, but we need to worry during the period of P to C, that is the recession curve, recession period, because there is no rainfall at that time, only evaporation, or that means aquifer is discharging only, it is not recharged. So that is why we need to concentrate on it, and we need to analyze the portion, that is the recession curve. How we can analyze the recession curve, or how we are able to quantify the portion, quantify the volume of water available in the aquifer during the recession period. For this, two equations generally in use. One is Bosenick's equation and another is Maillet equation. So Bosenick's Bosenick equation is in this form, and it is hyperbolic in term, and here also there is one quantity alpha which is known as coefficient of recharge or recession coefficients, and it depends on aquifer properties. And for Bosenick's aquifer, spring aquifer is considered as isotropic, homogeneous, and with moderate head. So, but generally Maillet equation is used because it is easy to interpret, and it can with the help of it, many features of spring discharge during the recession period can be explained. For Bosenick's consider spring aquifer is linear. He considered that spring aquifer is behave linearly, because that means discharge is proportional to volume. But that means how much of water is available in the aquifer, then accordingly it will give the discharge. It is linear type, and there is this flow is unidirectional. That like that flow through a pipe, because through a pipe, if you consider a pipe, then water is flow only one direction. There is no vertical direction or any x or y z component. So may let consider that water is flowing only one direction. Second, discharge from the spring is exponential, behave exponentially. What is exponential decay? That means it initially decrease faster than its decrease rate going reduced. That means it is not fast as the initial portion, and it decrease and ultimately approaches to zero, but not actually it touches zero. That means in the say in this pot, in this say there is a drum, and here is the outlet portion. If you open the outlet, then water will decrease. First time it will decrease very fast, but after it touches this portion, then decrease rate will be decreased. That means the initial portion is like this, and then this portion, and after when it comes just touching that line, then it will behave this way. So water from the spring aquifer decreases exponentially, and it can be represented by this equation, this exponential equation. Q is equal Q naught into exponential function minus alpha t minus t this. This is minus alpha because water is decreasing. If it is increasing, then alpha will be positive. Okay. So what is the physical significance of this recession curve when we plot it through using Maillet equation? If this alpha angle is more, that means there will be 2 to 3 possibilities. When alpha is more, then aquifer permeability may be high, aquifer transmissibility may be high. If aquifer permeability is high, transmissibility high, that means the aquifer will deplete itself very fast. But if the storativity is storage area is high, storage of water is high, if the spring area is high, then alpha will be small. That means it will sustain for long period. That means during the no rainfall season, the aquifer will sustain the spring. Remember that equation, Maillet equation. Q is equal Q naught e to the power minus alpha t minus t dash. If we take logarithm in both sides, then it will come like this, because logarithm of exponential function, and with base 10 it will give 0.4343. This value is 0.4343, and ultimately it will give the solution like this. Alpha is log q naught minus qt, log qt divided by 0.43 and delta t. Now what is this in this graph? You can plot this in a semi-logarithmic graph. The first portion, that means this part of the exponential function, it will become a straight line in logarithmic plot. This is the initial discharge, Q naught discharge, and this is the Q1 discharge. If you take the difference, logarithm of this Q naught by Q1, and take the time value, this is in days, then it will give a recession coefficient alpha 1. Similarly, for this break, this micro regime, it will give another function, recession function alpha 2, and for this third regime also it will give another recession coefficient. So ultimately, if you can determine the volume of each micro regime, let's see, for this first micro regime, V1 is the volume. Because by using this formula Q naught by alpha and you convert it in the days, then you will get the value of V1, V2 and V3 for all the regimes. Then we can find out how much water is discharged during this recession period by subtracting initial volume with the final volume. And this is one case study that we have carried out during 2008-9 in Papumpare district, Arunachal Pradesh. There is a spring near the Naharlagun market area. We measured that spring daily, and this is our spring plot. This is the spring discharge hydrograph. This is our rainfall. You can see that's almost the spring discharge peak area corresponds to the peak area, peak rainfall season. And after stoppage of rainfall, you can see that discharge is decreasing, first very high, then it decreases slowly, and after that slowly. We prepared a recession curve. This is our discharge value in cubic meter per second, and this is our time value. Then you can see that we are taking, because this portion is not very long, quick discharge, quick draining out of water from the spring is very less in 20 days. After that it flattens and it flattens, and we calculated different parameters using our discharge value and time value, and accordingly we found out our recession value, recession coefficient value for the first micro regime, second micro regime and third micro regime. Then again we calculated volume for each period. And this is the total groundwater discharge during the 3 micro regime. How much it is? 3,378 cubic meter. And with this amount of water, we can feed 55 people during our recession period. And another important applicability of this recession curve is that we can predict our discharge in certain time period. Say after stoppage of rain, we want to know the discharge after 30 days or 50 days or 200 days, we can calculate this discharge. And it can be also used if we take some measures to recharge our or augment our spring discharge, and we can see whether our effort is successful or not. If our depletion time increases, say in this case, it is extended up to 180 days. Say before taking any measures, the spring discharge almost zero during 140 days. We adopted some measures, and after that we can see that this is increases up to 200 days. That means our research plan is successful in extending our recession period or depletion curve to 200 days. So this is one utility of our recession curve analysis. Then again we can calculate our spring aquifer recharge also by using using the discharge volume of initial volume and again last volume, and total discharge during that period. Say this is our initial discharge, this is our last discharge. From Q1 and Q2 we can determine our volume, and with the total volume we can calculate how much water is discharging in our aquifer. So this is about how to analyze our spring hydrograph to know the dynamic storage as well as spring aquifer research. So now we are discussing some other methods, not very generally used. These methods are not very much used. This is our water balance equation. There are some inflow component. What is water balance equation? Inflow minus outflow is equal change of storage. That we have seen our hydrologic cycles, and from this we can determine this water balance equation. This change of say this is our main inflow component is our precipitation, and main outflow component is our evaporation and transpiration. With this we can prepare this our water balance equation. And groundwater extraction, and it can be converted up, it can be written like this only. This is one nomograph used by David Todd. Here we first calculate the spring recharge area using our spring discharge, evaporation, precipitation and evapotranspiration. And when we plot this spring discharge against our spring discharge against our recharge area, then it will give our spring recharge, how much water is infiltrated into our spring set area. So what kind of data is required? Spring discharge data, precipitation data and evapotranspiration data, and these are how we can get this data. It is written also, and it is assumed that delta S can be considered as 0 if conditions in the source area remain constant throughout the year. So that means there is no groundwater extraction through pumpage or other area. Discharge from other sources from such as return flow from pumping or other sources can be considered nil. So this is another example in where we carried out spring study during 2008-29. Here we have plotted we have calculated these different parameters using the formula given there. Here you can see the maximum recharge is 76.9 mm and minimum is 42 mm. That means this is very less recharge and this is very high recharge. This is moderate recharge, not very much, because our rainfall is 2948, but our recharge is maximum is 76.9 and 41. So what is our recharge efficiency? It is nearly 3% only, because the spring is located in an area which is highly slope is very high, and there is no forest cover, and runoff passes through quickly. So there is little scope for slowing down the runoff. So if we can construct some recharge trends or staggered trends, etc., then it will give some time for recharging aquifer. So this is there we can interpret the situation like this also. And there is another methodology which is used in GEC 2015. This is done. This methodology is prepared by central level expert group for groundwater research for development of groundwater research resource methodology. and it recommends GC. The main thing is that related to spring, the GC recommended that wherever spring discharge data is available, the same may be assessed as a proxy for groundwater resource in hilly areas. Because for hilly areas, we are not calculating groundwater resource. Because we consider that if slope is more than 20%, then it is only goes out from the system as runoff. There will be little scope for research. But GEC considers, GEC 2015 methodology considered that it can be considered as proxy groundwater resources for hilly areas. And the assessment of spring research would constitute replenishable potential groundwater resource, but it will not be accounted for categorization of groundwater assessment, at least to the near future. So what is the methodology? Spring discharge is a form of annual extractable groundwater reserve. Are you aware of the groundwater resource of Northeast India or India? Do you know about groundwater resource estimation? If you know groundwater resource estimation, then you can know that what is annual extractable groundwater resource. So spring discharge is a kind of annual groundwater extractable resource. How it is calculated? The potential groundwater resource due to springs Q into number of days. What is number of days? That means if for a monsoon season, we consider that from March to from June, July, August, September, these 4 months is monsoon season. For what is the number of days? And if you take spring discharge for this period, then if you multiply number of days and discharge monitored during the monsoon season, it will give the research of groundwater spring research during that period. So accordingly, we have calculated groundwater researches for Meghalaya for spring, and you found that it is nearly total potential spring research in Meghalaya. I have taken it for 2020. It is 1912 hectare-meter. For monsoon, it is more, and for non-monsoon season, it is less. So these are the different types of methodology we use for calculation of spring research. For dynamic spring research, we have to analyze the hydrograph. We have to prepare the hydrograph. For this, we need spring discharge monitoring. Spring discharge we have to do. For this, daily measurement is best. Weekly or fortnightly measurements also can be practiced. But for monthly measurements, data is insufficient for recession period data analysis. Because if you take only monthly monthly data, then it will not find the break in. You will not get the exponential decay curve, because you will miss the data somewhere. Like that is one I have shown earlier, one curve. Here you can see this is monthly measurement. You can see there is, you will not find any break in the monthly measurement, because it is from probably from December to January, February, March. There is no break because rainfall already ceased, but there is a no break. It is only straight line. So monthly measurement is not give you the exponential decay of curve, exponential decay of discharge in this monthly measurement. So it is best practice to get at least fortnightly measurements of spring, so that you can plan your management plan considering the spring discharge. So this is all about. Thank you. Any question? Okay, thank you.
So, in a nutshell, during the implementation of this green check development program, better if you start monitoring. After implementation, one question will come up with you that whether there is any change in implemented effectively or what is the outcome. That's some data. That's the source and only you can get. And if both the data whether there is any changes happens on implementation of this or not, that need to be considered because other factors may also affect rainfall change. So if rainfall changes, for that happening, that also is a factor. So many factors will come up. So every implement something, so you have to submit a report, impact assessment study. So if you don't have a letter, in most of the cases you are finding we have implemented our discharge this month. Why is the earlier? Platform is to put up to prove that. So better like that. So that is important. You don't need the quantum of those available. You cannot plan for that. Maybe a typical thing you have seen some calculation, this and that thing. In time you can do some exercise if you have any interest on that, because that quantum based on that and for whether how much people you can serve the quantum and how long you can serve, or you have to make some alternative arrangement. It may not be possible if you are finding that this is running on implementation or before implementation up to this on implementation changes in this and how long you can February, March, these 2 months or 3 months if you cannot supply, it is not giving water, then you will have to plan accordingly. So like that I think you can do some exercise by yourself for that. Try to collect that data. Sometimes you can put also, if you have interest, you can collect the spring discharge data. Nowadays different, they have shown probably plume and all other arrangement is there. Continuously you can monitor that water level, discharge data, and from rainfall data also collect. You can collect from nearby station, or you can put up on rainbow station and just plot rainfall versus
Right.
discharge. From that you will find different peculiar phenomena. Sometimes you will find that when rainfall is picked up, that is also. And sometimes you will find that after rainfall cease, after 2 or 3 months, it is. So this type of different phenomena you find is very interesting. So don't think only on mathematical calculation, which is making some puzzle. Go through that, you will get some some patience and interest, then only you will yes, it is only you will find this type of why it is happening.
Sir, I am saying that all are government entities. Yes, sir, when project was started, then state government or central government say go and start the work. Before starting the work, what is the basic background of that point or that thing or any kind of water? No data is available. When then we collect